Well, welcome back to ye old Foundry, ladies and gentlemen. Um, I've said in the past. Well, by the way, here's my wall of fame. This is all the famous I am. Okay. This was given to me by the Navy. It was nice of them. And then here's my certificate of retirement. Loving it, loving it. Okay, anyway, as I was saying in the past, there's many ways that you can take advantage of learning the foundry trade. Let's say you're on a farm. You got all kinds of equipment that little things break all the time and you have to take your time off. Things are, you got to go down to the local store or send away for the part that's broke. And in the meantime, your machine's down. Okay, and that's going to stop you from doing your work on the farm. If you're on a ranch, almost the exact same thing, maybe not quite as many tools, quite as many machines, but you're still going to have the capability of replacing things that are broken. Okay, if you go far out and really work up your furnace and your capability of melting, high temperature metals like ferrous-based metals like iron and steel, you can replace almost anything you got, especially if you're one of those guys who's got a farm or ranch and knows how to use a lathe. Man, you're right on. You can get this stuff done really nice. Okay, you save a lot of money too. But then there's people. I have the automatic light on. Sorry for that sudden scary stop. But there's people like me that I live in suburbia. The only thing that I have to really replace are the oddball things that are worn out or got broken, and that's fairly easy for me. But I'd probably say the hardest place to do this kind of trade would be in the city. But if you've got, let's say, a space that's big enough to be like a small garage, or you've got space in an alleyway and you're not going to be possibly burning anything up out there, you can even do this in the city. I wouldn't say you could do it in your apartment, okay, because you're talking about generating gases that you don't want to breathe necessarily. You'll be generating a lot of heat, and if for some reason your metal has a pop or splatters, that metal will be just as easy as using a blowtorch to catch something on fire in your apartment. So extreme safety should be applied. Dang, I know I got this thing. I'm gonna have to get out of this hallway. Okay, so a week or so ago, I went and found that in my master bath, let's get me some more light. In my master bath, something fell apart on me. And as is usual, you're going to buy something in the store that you thought was going to work real good for you, and really part of it wasn't all that great. Okay, here I'm in the shower, and no, I'm not taking a shower just for you guys. What I have, we went and bought this shower head, and it's got a holder for this portion. Okay, problem is when you get it up there, the whole thing has a tendency to turn, and I didn't like that at all. So I decided to go ahead and make something with my 3D printer, and this was it. Okay, it's wider at the opening here than it is here, so it allows this to sit in it without it falling out. And it's this lasted a few months for me before it cracked right here. And there was little wonder, because when I looked at it, it barely had the skin of a onion's thickness of material holding it together. Okay, so here comes the foundry trade to the rescue. What I'm going to do is I'm going to make this. Now I'm not going to make it out of aluminum because I don't need an aluminum thing here. I just need something that's solid. So the next sturdy material that I have on hand, no, not lead, because lead, well, it could be used too in a pinch. But I've got a bit of zinc that I can use. Zinc, when you pour it into a shape like this, it's going to be hard, and it's going to be it's going to last ages. Okay, probably longer than this will last. So which means that I'll have this on the wall, which is, this is where it was before, and then when this fails, I'll go ahead and get something that's very close to this. At least it has one of these on it, and then I'll still be able to use this. Okay, so there's the setup. This is the project. So I'm going to go back. I'm going to go out to the foundry area and show you what I'm going to be doing next. I'll be right back. Okay, now we're back out in the garage where I have my little foundry set up. Now, what we're going to use this time is plaster of Paris. Just like the good old lost wax method, use plaster of Paris. Encase this in plaster of Paris, leaving one side open for to pour your metal into, and then once it solidifies, it'll have the perfect mold cavity for you to pour the molten metal into and replace this. Okay, now you have to have something to go around the item that you're going to make. So you make my best thing was to just get a can, take both ends open, and it's got to be big enough for this to fit. I was going to do it this way, but I think I'm going to do it this way because it's a bigger opening up here, and all the stuff that I want to replicate will be a little bit further away than like when it would have been this way. Okay, so first thing you got to do is you got to get a base. Okay, get something to put that on, and it's got to be in a place in the middle of it, but it can't move around because you're going to be pouring plaster of Paris in there, and just like if you poured a cup of water in there, if this is loose, it's just going to get pushed out of position. So what I'm going to do to try and get this where it's going to stay in one place is get some of the double-sided tape that I have and put it on the bottom so that this will not move. This piece of tape is junk. Alright, well I'm not even gonna, well, let's see if that might have been just out in the open to where it got non-tacky. So let's try this. It's good enough for my finger, but not good enough for this. No problem. I can do something about that. What I'm going to do is just put a little bit of caulking on the bottom of this, because I will be needing the caulking in a little bit. Then I'm just going to press this into place so that it'll stick. Okay, now if you have a pneumatic vibrator, I expect you'll probably get it, because if you've ever used plaster of Paris, once you mix it up, it's got a bunch of bubbles in it. Okay, it captures the bubbles. You don't want any bubbles forming against your pattern. Okay, so you get something to vibrate this with, even if all you do is just hit it with a screwdriver or something like this, and you just, the whole thing, you hit it, maybe that'll help with the bubbles rising. Okay, the whole deal is you want plaster of Paris 100% pure, smooth face against your pattern. Okay, because the better the facing against your pattern, the better your casting is going to come out. You can use this for almost anything, especially if, let's say, you have a little little statuette that you made out of you know, wax, and you go ahead and make something like this. You have the statuette in there, and you can pour it from, on the other end. You don't want a bunch of bubbles on a little statuette, because it's going to really look rotten. You'll have to do a little extra work to get those inverse of the bubble. You know, the metal goes into the hole where the bubble was formed, and then it looks like a bunch of warts on your project. You got to get them off. Okay, save yourself some trouble. Get something that's either going to vibrate the whole assembly, like the pneumatic vibrator that I have here, or get something that you can use that you can, you know, either tap it on the side or go around it like you're trying to tamp in sand, and that'll hopefully displace any bubbles that might have formed against it. Okay, so this is now in place. Okay, and now, and I've pre-drilled where this is going to go. Okay, I'll go ahead and get a nut and bolt and bolt it against it. Now the next thing is, you got to get this pattern centered up in your mold, or rather it'll be your mold. It'll be a plaster of Paris mold. Okay. Yeah. Now you don't want the plaster of Paris to pick this up and leak out from underneath, because it is gonna, at the very beginning, gonna be like water. Okay, so it'll have a hydraulic force being exerted against the crack that's all the way around there. You don't want that. So what you do is you take your caulking and put a bead of caulking all the way around. Okay, it'll not only seal up that crack, but it'll help hold this mold, or stainless steel. Not stainless steel, it's just regular steel with a tin covering. Anyway, it'll hold that in place, and once it hardens, it ain't gonna move until you pry it loose. Okay. I have used this stuff when I was in the Navy before. I was always kind of experimenting with new things. You know, if you didn't, all you had was just the experience of using Petrobond sand. And while that is great, and it does teach you a lot, it's better to learn all different types of molding techniques, and this is one of them. Using the plaster of Paris. Okay, that's basically done. I don't need this anymore. Now I'm going to see how this is. It's actually nice and steady right there. Okay, but what I'm going to do is I'm going to bring my finger all the way around. It'll do two things. It'll make the seal around a little bit better, because it'll be pushing it in towards the crack a little bit more, and it'll add more size on top, on the side of this and on the side of this, so that it fights movement even more. Okay, so I'm just going to do a little bit of making a fillet around the outside here. And then what I'm going to do is I'm going to secure this assembly here to my molding bench with some screws, so nothing will move while it's being poured. Okay, now I want the hole on the outside. I'm going to get this off my finger before it solidifies. And I don't need the caulking anymore, so I can put it back on the shelf. If you're a young person, want a bit of advice an old person like me can give you is clean up when you can. Because once you get the job or project completed, you may not be in the mood to clean up after yourself. But eventually you're going to have to do it. You know, if you have any self-respect, you're going to want a clean shop. All right. If you grew up in a place where it's nothing but junky and you're used to junky, forget everything I just said. Okay. Now, the double-sided tape can go. I'll get put away in a minute. But what I'm going to do is I'm going to arrange this where the vibrator, I'll be able to attach it easily. Don't want to do it that way. Doesn't make any much difference, I guess. Okay, well, see, the thing is, you've got two ledges here. You got a short ledge and a long ledge, and I'm going to have to use the long ledge because it's going to be pointed out this way, and it'll be easier for me to put the hose on it if I do it that way. Okay, now I can't do it. I've got to put it there because I have to have access to the hole to be able to put the bolt on it. Okay, now let's get my drill out. Am I going to be able to reach? No, I won't be able to reach over there, so that means I'm going to just get me a little. See, I've got my other extension cord, and it's being used now on something else. So, for me to work on this, I'm just going to get me one of the old cheapos that I have hanging around here and use it. Okay, we're looking at the sky right now, so I may as well put this where you can see a little easier. Couple of them. I only want to just secure it so it can't move while it's vibrating. You know, I mean move all over the place, because this is not light. Okay, this is kind of heavy. It's probably almost 5 pounds, 4 or 5 pounds, and it would have a tendency while it's vibrating to pull this whole thing down. I don't want that, so I've got to secure this so it won't move. Yep, that's good. Well, things go bad. Sometimes. Good thing I got more. Good thing I got more stuff. I can just reseal it. It's always a good idea for people to think ahead. What will this do if I turn this on? Well, in my case, I didn't have my one hand on it to keep it from moving while I was screwing in there, and you saw what happened. But not that much damage done. Just a little bit of embarrassment. Oh my God, there goes my godhood. I ever thought everybody would think I was a god with my ability to work with Foundry stuff and you know, molten metal and all that. Darn, I've done exposed myself as being like anyone else. Okay, being sarcastic, of course. All right. Now, I know it's not going to move, but I ain't taking a chance. That's in. This other one's in. Now, that is not going to move. Ta-da. Okay, now, set this aside. I'm going to go and I'm going to find the plaster of Paris that I have. No, that's not. I got it all marked, so I'll find it. I'm going to find me a mixing container so that I can mix the plaster of Paris and water. Just for anybody who has never used plaster of Paris, super simple. You get your plaster of Paris powder. You can get it from any place. You can get it from Home Depot, Lowe's. You can get it from any of the craft stores like Michael's, for instance. And by the way, just in case you think, I'm not getting squat from these people to mention their names, so they're getting free advertisement. Maybe someday they'll be nice. I wouldn't count on it. They're business people. Business people aren't all that nice sometimes. Anyway, as I was saying, get your plaster of Paris powder, and it's a 2-to-1 mixture. 2 parts, whatever size. It could be 2 cups, it could be 2 gallons, it could be 2 55-gallon drums, depending on how much you need to make. But it's 2 parts plaster of Paris powder, 1 part water. Okay, so I'll be back in a bit. I'm going to get me a container to mix in. I'm going to get me some water, get me a little plaster of Paris powder, and I'll be back. Okay, we're back on. Got myself a little mixing bowl. Okay, are you aimed at the right direction? Not very well. All right, got myself a little mixing bowl. This is one that I actually do use here in the Foundry. Got water in there. Okay, got a cup of water in there because what I'm gonna, this is part 1, and the plaster of Paris powder is part 2. Okay, you get 2 parts plaster of Paris powder, 1 part water. Put in the water first. You put in the powder first, you're gonna have, eventually you'll get it mixed, but you'll have a heck of a time doing that. Okay. Got me a little spoon that I've used to mix with. Okay. I was wondering what that hissing was, and it's my pneumatic vibrator. Getting me a cup of plaster of Paris. Try to make it as good as you can. Now you mix this very slowly, okay? At first it's going to be nothing but discolored water, okay? But as you mix it in, things will get a little thicker and a little more like what you think plaster of Paris should be. Nice and thick. Now, this stuff hardens through a chemical reaction, okay? There are people out here that use this every day, and they can tell you how to make the reaction go faster or how to make it go slower. You would want it to go slower so that you have more of your bubbles get out if you don't have a vibrator. The vibrator helps it immensely to the bubbles to rise to the surface of the liquid. And don't forget, don't just throw it all in there. You want to try and get it all mixed as smoothly as possible so that the stuff will flow over your pattern and, you know, copy the pattern as religiously as it can. Religiously. Well, I suppose if you're religious, you would be able to, you know, go with that word, but as faithfully as possible. You want this stuff to replicate the shape as faithfully as possible. Maybe that's what I meant in the first place. You know, if you're a religious person, you're going to be faithful anyway, aren't you? Okay, I got most everybody in the first batch. You just keep mixing it until you don't see no lumps anymore. And of course, this is kind of redundant to anybody who's ever used plaster of Paris before. They've got some stuff out there that we used while we were in the Navy. It was actually a kind of a plaster of Paris, but it was the stuff that they use up in the dentist's office to, you know, copy dentistry, like around your teeth and your gums and all that. All right, I gotta get my second bit. Now, if you're gonna get yourself a bag of this stuff, don't forget that plaster of Paris absorbs moisture very easy, and you know, it's like having a bag of cement out in the rain. Your bag of cement is ruined. You can't utilize it the way you wanted to use it before. So try to isolate this from moisture so that it can be used later when you have a project. I mean, I've had this for more than a year, and it is as powdery as it was when I first opened it up, and that's only because I isolated it from the outside atmosphere in this Florida humid atmosphere. So much moisture in the air when it's summertime around here. Not only very uncomfortable, but I'll be darned if it doesn't ruin a whole lot of stuff that combines with water. Let's see, do I have any more stuff in here that I have to mix? It's starting to get like paint now. Like some of the paint, it's getting the consistency of paint, I should say. The kind you would open up in a can and just wipe on your walls, paint on your walls. It's that consistency right now. I would show you, but see, once you get this stuff all mixed in, the chemistry is starting to react already. Now, this would, if I left it like this, it would last probably till tomorrow before it really got, solidified. But once I get the proper ratio mixed together, it's only going to take maybe an hour for it to be totally done and hard as a rock. Okay. Do you have any more lumps in here, mister? No. Okay, and that's the end of that. See if I can get this stuff mixed in quickly. I mean, it's not gonna solidify. I mean, if you were to be putting this stuff together in hot water, that would certainly make it go faster. That would make it solidify faster, because there's, I mean, you don't necessarily have to go to college to learn this stuff. You can read it in a book. But one of the things I took away from my chemistry class, for good or for evil, is that you have three things that make up a chemical reaction. First, your basic material. Second, your heat, and which you know helps in the chemical reaction, and then your catalyst, whatever it is that you add. Because you can have 2 out of 3 of those things sitting there and it won't do anything, but once you get the third part in there, it starts the reaction. And right now I'm just trying to make sure that I get it all nice and mixed, smooth. We don't want any lumps laying against the mold cavity, or rather against the pattern, to make an unusual cavity. Okie dokie. Now I'm going to pick you up and hold your ears, because I'm going to turn the vibrator on, but I'm going to put you over here. I'll tell you what, I'm going to shut that door, because there's going to get better, that we'll have better light pointing down if I shut it. See the light above the bench? That's what I'm talking about. Okay. Now I'm going to turn on the vibrator. I'm going to aim down there, and you'll be able to see it all go. you can see, the bubbles is coming up, but I gotta put a little bit of weight on it. Because me being in a hurry, I wanted it to, you know, pour it right away. The problem is I didn't make certain that the, you know, caulking had dried sufficiently. So a little bit dripped out, but not, it wasn't disastrous. So I'm gonna pause you, and I didn't make enough plaster of Paris, so I'm gonna make another batch and fill that the rest of the way up. I'll bring you back when I'm done. Okay, I put the pneumatic vibrator away. I put my hose and pneumatic stuff away. I've also gone ahead and filled this the rest of the way up, if for no other reason than just to back up the thin part. Always make extra. Good idea. Always make extra. Now I had thought that 2 cups of plaster of Paris and the water would have filled that up. I misjudged it. So, but the good news is plaster of Paris is good enough or easy enough to use that you can make another batch real quick like. And if you get there fast enough after you're done making your batches and you want to clean up your equipment, a good spray with the hose, and usually that stuff just goes away. Now, I've gone ahead and taken this all loose. So I know this is not solid, but it's not going to flow. And so I'm going to take this loose. There you go. And look at this side. Now, that's almost completely solid, okay? And you can see where the pattern is. Once this gets totally dry or totally solidified, it'll be easier to work with. All I'm going to do is to expose the entire base, which I think is going this way because it looks like it. And then I'll show you something else. Something new, something I've never done before, and well, most everybody that I know says it works nice. So I'll bring you back then. Hey, welcome back. Okay, now what I'm doing now is something I've never done before. The material I use on my 3D printer is one of the cheapest plastics you can get, but the thing that it's unique about, it'll last a long time, but it is affected by water, so you can't make anything that you're going to hold like a bottle and you're going to put a liquid in it, because it'll just, you know, dissolve and the stuff will leak out. And it's basically a little bit less temperature, but that's a good thing, because what I've been shown on YouTube is that this plastic will melt out like wax does. Okay, so this is the reason why I'm using the thing I made, is I'm trying to melt it out like wax does, and so that it'll make the mold cavity. Now it's supposed to, well, I don't remember what the temperature was in the 3D printer. Seems to me it was like 250 degrees, or maybe it was 250 degrees Celsius. Not real sure. Don't recall right just this moment. But as you can see, I've got the mold sitting on something, raise it up so that this can sit. This is another holder that I made out of that same ABS. That's it. ABS plastic. And so I'm shooting a jet of very hot air against it to see if it'll melt. Now what I'll probably wind up having to do is get closer, because it seems like it's not that hot. I mean, I can put my hand in front of it just this long. If I tried to leave it there, I'm sure I'd get burnt. But this is what I'm doing now, and it's a big experiment for me. I think I probably could put it in the oven and just melt it out, but I'd be afraid that the ABS might leave a layer of plastic inside the oven that might mess with the food that we make inside the oven. I don't have a industrial oven where I can put this in there and not care what kind of fumes that it generates. So I'm going to use this, my heat gun, to try and melt that out. And if there's any real good changes in this, if it starts melting out, I'll bring you guys back. Okay. Okie doke. Well, I melted it out, but it didn't do with the hot gun. It didn't do, because eventually it might have, but that thing was even at the highest temperature setting on the gun, it still didn't start moving anything. So I went and got the propane fuel, the little one, and that did the trick. Okay, now some of the stuff, it did come dripping out, okay, but then the stuff that's left in there, you had to turn it into charcoal, turn it into ash, and even then it's not really, let's see, you might be able to see that the central part of it, which is like the most important part of it, looks like it looks good, but the outside edges, I'm gonna have to work on those. Now if I knew for a fact that that stuff would float like styrofoam, then I would just go ahead and pour the zinc in it. But before I try and pour the zinc in it, I'm going to go ahead and scrape it a little bit. See if it cleans out. There's not going to be very much in there. This right in here, way at the corner, it's a little thicker, but the stuff on the wall just peels off. So I'll let this thing cool until tomorrow, and then we will see what we see. Once I get it clean enough, because I really don't want to pour the zinc over it. If that stuff doesn't displace easy and doesn't rise on top of the molten metal, it might just bubble up, like encountering liquid or water, and I don't have any other copies of this, so I'm going to do as best I can. Make sure that I really don't totally ruin it. It's, even if it's only half there, it's still going to hold that thing, but I'd like to be able to do as good a job as I can, make it as good looking as I can. Heck, I'm 66 now. By the time that ever has to be replaced again, my wife's next husband is going to be doing it, unless he can't do things. Then it'll be somebody else that takes over the house once we pass on. But I still have to work on it. So I'll bring you back as soon as I start working on it, okay? And that'll be tomorrow sometime. Bye-bye. Okay. I went and, as best I could, melt out this form in the plaster of Paris. I used this propane torch to melt it out. I started off using this heat gun, but the heat gun was taking so long for anything to start melting, despite the temperature I had it set up at. you know, which it maxed out and still wasn't doing much at 1250 degrees. So I went and used this, and it melted everything out. You know, here's some of the debris that was left over, and so the vast majority of it I got out, and then I started trying to remove the rest of it using small hand tools, like little scrapers like this, going in there and trying to scrape stuff out. I found though that while I was doing that, I was starting to degrade the plaster of Paris in there. I was scratching it up and messing it up. So I stopped. I got the vast majority of it out. Now what we're going to have to do is we're going to have to see how violently the molten metal you know, reacts to the leftover that's inside there. Does it run over it and cause a big gaseous explosion, you know, like running over water, or will it just melt the remainder of it and float it off? We'll find that out. So what I'm going to do is I'm going to get my stuff out. I'm going to get the melting, like I got my big old ladle right here. To melt, in which I can melt the remainder of the zinc that I have over here. And I got a unit over here, stuff in the way, that I can set the ladle on to melt it out, which in the past I had a this pot here on, iron pot. This is what I'm going to use to melt the zinc, and then once I get that all set up, and just before I pour that zinc inside that, I'll go ahead and bring you guys back. I still have to grab the you know, propane tank and put everything in place. Get my face shield, get my gloves from over there. You know, this is not exactly like pouring aluminum at 1250 degrees. This is only about half that temperature, but it can still be dangerous if it ever popped. Now what I'm going to do is I'm going to get a shield. Let me see if this is big enough. I'm going to get a shield to put over this opening like this, put a weight on top, and then pour inside this little gap. If it does happen to start popping and stuff, the shield with the weight on it will keep the stuff from flying all over the place. Much like when we, in the Foundry, when we went and you know, done with a heat in the furnace. You know, we see the everyday process that we did is we didn't really ever have to go through the calculations and see how much metal we had to have in the crucible, because all we all we did every day was to just put enough metal in there, like to fill it 3/4 the way full, and then once we, you know, poured all the molten metal and filled in all the molds, the excess we poured in to a couple of the the big heavy walled, like an inch thick heavy walled you know, steel molds that were something like this, except this would have been made out of steel an inch thick. Okay, now we would put a shovel over it and then pour in one end, and if there was any moisture in here that collected since the last time we poured the molten metal, the shovel will have kept the stuff from popping out and getting on anything or on anybody. Okay, and that's what I'm going to do with this here, and should be fine. So I'll bring you back as soon as I get everything set up, and just before I'm going to actually pour the thing, I'll bring you back. All right? Okay, it took a little while, but it's finally you know, molten. Let me get this chair out of the way, so if I have to beat a hasty retreat, I can do so. Now, always plan ahead. You never know what's going to happen with molten metal. You're going to know what probably will happen, what's likely to happen, but there's always something, like we used to always say, the gods of molten metal are fickle. If you don't do everything perfectly, they're going to throw it at you. Okay? So, all I got to do is put my face shield on, get my gloves on. I've already got my apron on so that if it splashes me, it ain't going to splash much. The thing about lower melting temperature metals, like iron, not iron, but lead, tin, zinc, it's different from the higher temperatures in that with the higher temperatures, if there's a big spurt, like it runs over some moisture and it, you know, has a steam explosion and some of the molten metal goes flying in the air, if it lands on you, yeah, it burns you, but it's like it cauterizes the wound right away. I mean, immediately. So all you got to do is, if it lands on you, you just shake it off, and you'll have what looks like a little crater there, but it's already cauterized, and you're not going to get an infection. Not likely. With the lower melting temperatures, if it spits out and lands on you, it doesn't turn into a BB like the other metals, the higher temperature metals. Before it hits you, the molten metal let's say it hits your arm, it spreads out and grips you like molten plastic. If you've ever played with plastic and got it on you, you know how bad that is, because it grips you and you got to grip it and peel it off your skin before it does any real bad damage. Now the odds are good that it'll cauterize the wound too, but it's going to burn until you pull that thing off of you. So keep that in mind anytime you're working with molten metal. Alright, this stuff should be plenty warm now, so I'll go ahead and point you in the general direction. I hope that the lens allows you to see that. I'm going to point you down some. the stuff didn't float away. It didn't burst, okay, but I saw a lot of bubbling in there, which is really not the best situation. It's not the worst of all situations, because I would be worried about it blowing back on me. That would be the worst situation. But the stuff was bubbling, and I don't hold much hope for it to be a nice clean surface. Now, if it's just essentially a form that spray nozzle can sit in, I'll still utilize it. Okay, I'll just get rid of all the excess metal. Maybe if there's voids in there, I'll go ahead and fill that up with some kind of you know, caulking or some such thing. Then I'll paint it over. But right now it's just sitting there hissing, which that tells me that's the remaining moisture in the plaster of Paris. Hey, maybe I'm lucky that the plastic stuff, the ABS plastic that came out of the 3D printer, maybe it did just turn to ash, and that's not what I saw bubbling. Although I did smell a burning plastic smell. I don't have anything to grip that stuff with. Let me get a pair of tongs. And we'll see what it looks like after I remove that shield that I put there. That's a lot of, I just poured a bunch of moisture off of there. So maybe I'll be lucky. Maybe the bubbling was just moisture. And hopefully the damage will be minimal. The surface on the inside there was basically dry as a bone, because whenever I tried to chip that plastic out of there, some of that stuff went with it. Okay, so I'll have to let this thing cool for a little while. Once it gets cool and I break it out of the plaster of Paris, I'll bring you guys back. See you later. Okay, it's all been busted loose. The item that I made has all been busted loose. Now, my biggest worry was that the ABS plastic that used to be, this form used to be made up of, was going to stick on the inside of the plaster of Paris mold cavity and become a bad mess. I have to take that back. It's not. As you can probably see here, see, it's there's none on that surface, there's very little on that surface, none on that surface, and just very little on that surface. Now these edges right here, right there and right there, this is where the thickest portions of the stuff was, and there is some residue left there that hadn't been burned away by the molten metal. But everything when it comes to that plastic looks good. What I saw that caused all this bubbling that you see here was the leftover moisture that was in the plaster of Paris. Now, the thing that I found out about plaster of Paris is you can put it in the oven, and you put it in about 300 degrees, something over steam, you know, the temperature of steam, and you can try and dry out all that plaster of Paris. But if you're using plaster of Paris to and the plaster of Paris has a lot of definition in it, like filigrees or anything like that. The unfortunate part of heat in the oven is that the plaster of Paris becomes very powdery up to a certain amount, and so you lose a lot of your definition. Luckily, on this thing, there's very little definition, and everything I wanted to come out did come out. Now, I wouldn't get any. I wouldn't get a grade, a good grade for smoothness all around, but I count that on two things. Number one, that leftover moisture that I never gave a way for it to escape other than coming up through the mold cavity, and the fact that I didn't have any kind of a riser to take up the mass that this was going to be feeding. In reality, though, well, sorry, but I got a very, very windy day today. This is a couple, 3 days after I poured this. I got a very, very windy day today, and my wind chimes are going nuts. Now, I like my wind chimes, but they are being very, very noisy. Alright, so my next step is I'm going to be cutting off all the excess metal on this, and I'm going to smooth the sides up, take all the excess bumps and projections out of here, and paint it, and then put it on the wall. I gotta, in between that though, I've got to drill the holes for it, which shouldn't be any kind of a problem, but we'll find out. Okay, so when I start cutting this loose, cutting all the excess metal off of it, I'll bring you guys back. As it is right now, my little place around here needs to be cleaned up from that mess that I made. So, I'll bring you back in a little while. Okay, making progress on my little project here. Okay, I think you just saw what it looked like when it came out of the mold. Well, after some sanding and some filling in voids with caulking, this is what she's starting to look like. Okay. It doesn't look as good as when it came out of the 3D printer, but it does look pretty good to me, and it's absolutely going to do the job that I'm going to intend for. So now what I've got left, I've got to drill the holes for the screws, and I've got to paint this thing and then install it. I'll bring you back when I get that done. Okay, I'm back now. Alright, I'm practically finished, with this whole thing. Got it all ground off, excess metal off, tried to flatten up as much as I could, try to compensate for all the the pock marks and shrinkage and all that stuff. Like, for instance, there was some shrinkage in there. If I was making this out of aluminum, obviously I would have put a riser probably right about in here, and I wouldn't have had that. But the thing is, I don't care, because this is going into my bathroom. This is going to, that portion is going to be hidden against the wall anyway, and I got it all painted. I used some of that stuff that's supposed to look metallic, and it looks okay. It'll last. It'll last longer than I will last. Okay, so now it's a matter of getting the things ready to be sealed. Now this goes up. You got to, before you put this onto the wall, I put this onto the wall, got to make certain that I don't have any possibility of moisture getting into the wall cavity. Okay, so use some good old-fashioned caulking. Plus, you don't put a caulk all the way around, because you know, once in a while you're gonna wind up having some, like if water sits against this, it's somewhere around here it might leak in. So if you put a thing all the way around, the water's gonna be collecting inside there. Okay, so leave the bottom open so that if anything gets in here, it can drain out, or it can, because of the gap, it'll be able to dry out. It won't go inside the wall cavity. Never want no water getting inside your wall cavity, because eventually, depending on how long you're going to live in any one place, you might damage that wall. Okay, so going to put a little bit around there. Gonna have to grab the bottom because I think it's spreading out too much. Yeah, that's the top. Okay, leaving the bottom open, right? Okay. Now, let's bring you inside here. Okay, it'll be going right here. I think I've already shown everybody else what's going to happen. Now it's a matter of just putting this up on the wall, making sure I don't install it upside down. Started. Get this one in here too. I try my darndest to make sure that everything is nice and lined up so this thing can, you know, get on there nice and tight. But I'm nowhere near as talented as the guys that do machining all the time. I'm okay when it comes to foundry work. Hey, it's on there. And the wall didn't fall down. Neato. Okay. Now, the stuff that's squeezed out around here, I'm going to just spread it, kind of giving myself a little filament. Screws, so water can't get past the screws. I mean the heads of the screws. And there we go. Now pardon me for a second, I'm going to wash this stuff off my fingers. And here's what I wanted to happen. Now, when you're done spraying, you can just put it up instead of putting it way in the hell up here. And when you put it up here, this thing starts moving around. We don't want that. So, now this zinc, solid zinc holder holding everything in place, and this will not break apart. Probably 100 years it'll be here. Yeah, I mean the house, if it stays, that might stay there 100 years. And that's that. So I'm going to put everything together and get this online, and this may or may not be germane to anything in your life, but it might help somebody else out. Okay, go ahead and leave any comments you want. Please do like everybody else says, give a thumbs up or a thumbs down depending on your point of view, and I'll see you next time. Bye-bye.